In the previous lecture, we have had a look at how we represent any linear polynomial on a graphical form, right? So, we have seen that any linear polynomial can actually be represented as a straight line in graphical terms. Now, there is one more interesting point that we took note of, right? So, the point at which the graph of the polynomial intersects at the x-axis, the x-coordinate of that point actually gives us the 0 of the polynomial, right? Why does that happen? Well, the value of y is actually nothing but the value of the polynomial at the given value of x, right? So, at that point where the graph intersects the x-axis, we get the value of y as 0. So, this value of x actually turns out to be the 0 of the polynomial. Now, let's move ahead and try to find out how we represent a quadratic polynomial in graphical form. Right, so to do that, let's take an example. So let's take the quadratic expression x square minus 3x minus 4. Right, so we'll represent the value of this quadratic expression, this quadratic polynomial as y. Right, so now let's find some set of values of x and y which we can represent as points in the graphical system. So let's find out some values. Right, so you go ahead and give it a try. You can yourself find some values of x and y which satisfy the relationship y is equals to x square minus 3x minus 4. So here we have listed down some such set of values of x and y, right? Now let's bring out the graph and let's plot all these points one by one, right? So now you see that we have plotted all the points, all the set of values of x and y that we have figured out here, right? We have plotted all those values as points in this graph. Now the next step is to draw a freehand curve, right, to connect all these different points. So let's do that, and you see that a shape is emerging out of this, right? So when we connect all these points by freehand drawing, we see that a shape is emerging out of this. Now this shape is what we call a parabola. So any quadratic polynomial can be represented in this particular shape, which we call parabola, when represented onto a graphical form. Now again notice that there are two very interesting points on this graph. Have a look at the point minus 1, 0 and the point 4, 0. These are 2 points on the graph of the polynomial where the graph intersects the x-axis. So at these 2 points, the value of y or the value of the polynomial turns out to be 0. Right? So now these two values, so the x coordinates of these 2 points, right, which are 2 values, x is equals to minus 1 and x is equals to 4, are what we call the zeros of the polynomial, right? So in a quadratic polynomial, we have 2 zeros, right? So those 2 zeros are again represented by the x coordinates of the 2 points at which the graph of the quadratic polynomial intersects the x-axis. So now this is how we represent the zeros of a quadratic polynomial in a graphical form. Now, the graph of a quadratic polynomial, which we also call the shape that we also call as parabola, can be represented in multiple different forms. So there are 3 different cases that occur with the graph of a quadratic polynomial that we should be aware of. So let's take a look at all those cases one by one. So let's take a look at the first case where the parabola or the graph of the quadratic polynomial intersects the x-axis at 2 different points. Right? So now this parabola can either be open upwards or it can be open downwards. Right? So these are 2 different cases which happen where the graph of the polynomial, graph of the quadratic polynomial is actually intersecting the x-axis at 2 different points. Right? In other words, we can also say that in this particular case, we get 2 distinct zeros of the given polynomial. Right? We get 2 distinct zeros of the given quadratic polynomial. Now let's bring out the second case. So in this case, what we see here is the parabola actually intersects the x-axis at only one single point. Right? So the parabola intersects the x-axis at one single point. And now this parabola can also be open upwards or this parabola can also be open downwards. So in this case, we have only one single value of the quadratic polynomial, right? Of the zero of the quadratic polynomial. So this is the second case. Now let's have a look at the third case. So in the third case, we can clearly see that the parabola or the graph of the quadratic polynomial does not intersect with the x-axis at all, right? So there are no points at which the graph of the quadratic polynomial intersects the x-axis. Now this happens, when this happens, the parabola can be open upwards and the parabola can be open downwards. So now in this case, we can say that there is no zero of the given quadratic polynomial, right? Because there's no value, there's no point at which the graph of the quadratic polynomial intersects the x-axis. So these are three different cases which we see with quadratic polynomials that we'll discuss about a little more in later chapters, right? So now we have seen, up till now we have seen how we represent any given polynomial in graphical form, right? In more specific way, we had a look at the graph of a linear polynomial which turns out to be a straight line, and we also had a look at the graphs of a quadratic polynomial, right, which turns out to be the shape what we call parabola. So now let's go on ahead and have a look at the graphs of a cubic polynomial, and let's study the properties which are shown by the graphs of a cubic polynomial.